Now write a kinematic equation for the second half of the motion that will allow you to find the desired unknown that will answer the question. Your equation should not contain the fourth unknown quantity. Just write the equation, don't solve it yet.
So which one are we solving for at the top?
It's going to be y3, right?
Mm-hmm. This is what we're looking for. So which equation do you think we could use to solve for y3?
Well, the same one that we just used a second ago for y2, right?
Yep, so y final equals y initial plus b initial t plus 1/2 a t squared. So that means y3 equals y2 plus
that's 0, right? The initial?
So where are we starting from this time?
Oh, okay, we're starting from the second point, because we already did the first, between the first and the second.
Mhm.
So it would be a t.
Yep. So a t times our new delta t, which is this time right here,
Uh-huh.
plus 1/2.
And that would be a t again, right?
Yeah.
Or
well,
a t delta t
a delta t
squared.
squared. So why don't, actually, let's just leave this as v2 for a second.
Okay.
And this acceleration is a2.
Okay.
But now what's the problem with our delta t?
Well, we don't know what delta t is.
Right, because we don't know t3.
Yeah.
So that's our problem there. So how could we find t3 pretty quickly?
With a different equation?
Yep.
This one?
So we could use this one. Remember what I said about using these two equations together?
Yeah, you can.
A lot of times you can just use the third one instead. So let's look at, instead of taking this step and then trying to find time, let's look at what the other one does for us. So v final squared equals v initial squared plus 2a delta y. So v final is what?
It is 0.
Yep, so that'd be 0 equals v initial.
0.
That's this
Or,
v initial.
It's a t.
Yep, so this is at squared plus 2, which so would be equal to negative g.
So negative 2g.
2 times negative g times delta y. And this is what we're actually trying to solve for, right? We're trying to find this distance right here,
Yeah.
so that we can add it to this distance.
Okay, so we switched equations because we couldn't find, in that equation we had too many unknowns.
Right, this equation, we didn't know y3, and we still didn't know t3 either. So we had two unknowns,
Okay.
and with one equation you can't solve for two unknowns.
Yeah. Okay.
But this time, instead of, and you could have very quickly, I mean, if we wanted to, we could have just said v final equals v initial plus at, and we would have been able to say 0 equals v2 minus g times t. And then the only thing we would have known would be t. And we could have plugged that back into our our first equation and been able to do it. But if you see yourself starting to do that, just say, wait a minute, this squared equation, that's the one that kind of skips that step, and I'll have to solve for t.
Okay. That makes it easier.
Yep. So now delta y we can rewrite as y3 minus y2.
We know y2.
Mm-hmm.
We know y3.
So 0 equals at squared plus 2 times, well, let's just make it minus 2 g times y3 minus, what's our y2?
1/2 at squared.
1/2 at squared. So we know a, we know t. we know G, and we know A and T.
So would you just rearrange the equation and solve for y3?
Yep.
Okay. It's fun math.
Yeah, so what I like to do whenever I'm doing algebra is if I have a negative something, I'll try to move that to the other side. So I would move it to the other side like this. Let's say 2g times y3 minus 1/2 at squared equals at squared. And this is this way.
Okay. And then you would divide by 2g and add 1/2 at squared.
So y3 minus 1/2 at squared equals at squared all over 2g. Is it y3 equals at squared all over 2g plus 1/2 at squared.
Okay.
And if you want to, you can square this out so that you don't run the risk of, because you saw how I kept dropping those parentheses. So you can actually write it as y3 equals a squared t squared over 2g plus 1/2 a t squared.
Okay. That makes sense.
So
And then
then-
you would solve, well, that's as far as you can go with that, right?
Mm-hmm. But if you wanted to just plug your numbers back in, say that after this they just said, okay, actually it might,
Now substitute what you learned in part E.
and then simplify as much as possible. So you can actually take this now, because A equals 50 meters per second squared. You could plug that in here and here, and you could say 300 seconds, here and here, then divide by 2g, and that'd give you your answer.